So, to quickly review some of the key trends on the periodic table, we talked about atomic radius. And atomic radius is always going to get bigger as you go down a group, kind of like a snowman gets fatter as it goes down. And it's going to get skinnier as you go across. So, also like a snowman with a kind of like a twiggy arm, it's always like chubbier on the inside and then skinnier on the outside. So, francium down here is going to be one of the biggest elements, and fluorine over here is going to be one of the smallest ones. We also talked about ionization energy. Ionization energy is the amount of energy it takes to remove an electron from an atom, also known as turning it into an ion. So if I have an electron and I'm holding it really close to me, it's going to be a lot harder for you to try to take it than if I'm holding an electron out here. It's going to be a lot easier for you to take it because it's far away from me. Me being the nucleus, and this is my electron. This all goes back to Coulombic attraction, that positive and negatives attract. So the closer that the positive is to the negative, the closer that my negative electron is to my positive nucleus, the more that it's going to be attracted. The further away it is, the less attractive it is. Kind of like a magnet with a refrigerator. It's not as attractive to have a magnet that I'm holding from here in my refrigerator. It's all the way over there. But if I'm holding my magnet like up close next to it, then it will stick right on it. Also, how many protons and how many electrons are in the atom makes a difference, because the more protons and electrons you have, the stronger your magnet is, or the stronger the attraction there is. So, the essence is that it's harder to take an electron away from a smaller atom because the nucleus and the electron are holding each other very closely. They're very attracted to each other. So it's hard for someone to come by and try to take it. And so fluorine over here is a really small atom. And so it's going to be really hard to take its electrons. Fluorine also, it has 7 valence electrons, so it's one away from getting the magical number of 8, its octet that it wants. So there's no way that fluorine is going to give any electron away to anybody, no matter what. It's holding on with its dear life. So fluorine is going to have a very high ionization energy. This is different from francium down here. Francium's a huge element. And so it's holding its electron way out here, and it can barely hold on to it. So another atom can come by, like fluorine, and just swipe it because it's way far away. So ionization energy increases as you go towards francium. The next trend that we talked about was electronegativity. And electronegativity, similar to ionization energy, increases as you go towards fluorine. So fluorine is the most electronegative element on the periodic table. And electronegative means that it's the atom's attraction to another atom's electron. So now in our picture, we have 2 atoms. Before, for ionization energy, we just had 1. It was all about me and my ability to hold on to my own electron. But now in electronegativity, it's about my ability as an atom to attract another atom's electron. So if I'm fluorine and I'm really small and I really want one more electron, I am going to be very attracted to other atoms' electrons. I'm going to be like, I can just come right next to you. I can steal your electron. You wouldn't even know it's gone. Just let me have it, please. So fluorine is very electronegative because it's small. It wants one more electron, and it can easily steal other atoms' electrons. Francium is like the least electronegative atom on the periodic table because it barely wants its own electrons. It's not going to attract other atoms' electrons. It wants to get rid of its one valence electron. So francium has a very low electronegativity value. The noble gases do not have an electronegative value because they're not attracted to anyone, period. They're just, they're happy, they're good, so they're chilling. Group 18, they're minding their own business. The last characteristic that we talked about is metallic character. And metallic character is all about the ability of metals to lose electrons, which increases as you get closer to francium because francium is the best able to lose electrons. And non-metallic character is the opposite. So as you get to fluorine, it's best able to gain electrons. So they're nicely very opposite on the periodic table. Fluorine is one of the most non-metallic elements, and francium is one of the most metallic elements. Both start with F, so there's that. Francium is Fr, and fluorine is just F.